Beneath the sands of Egypt lie 25 massive granite boxes. Each one weighs around 100 tons. And to this day, no engineer has fully explained how they were made. In India stands an iron pillar that has resisted rust for over 1,600 years, while modern steel can corrode within decades. And in Iraq, archaeologists uncovered a 2,000-year-old battery, centuries before Alessandro Volta invented the electric battery. These discoveries don't seem to fit neatly into the history found in most textbooks. Today, we'll explore 7 real archaeological discoveries, each so extraordinary that they seem like relics left behind by travelers from the future. And we'll begin with the heaviest of them all. Every artifact you'll see is displayed in a real museum and can be viewed up close. Each one raises questions that could change the way we think about the ancient world. In 1850, French archaeologist Auguste Mariette was excavating at Saqqara, northwest of the Pyramid of Djoser, when he noticed a stone sphinx protruding from the sand. As his team uncovered an entire avenue of sphinxes, they realized it led to the entrance of an underground structure. When they entered, they had to use explosives because the passageways were tightly sealed. Behind the stone walls lay a vast maze of tunnels carved directly into the limestone. In the largest chambers stood 25 gigantic granite sarcophagi, lined up along both sides of the corridor. Each box measures about 4 meters long, 2.5 meters wide, and over 3 meters high. The lid alone weighs nearly 30 tons, while the total weight approaches 100 tons, roughly the weight of a fully loaded railroad car, despite being placed deep underground inside narrow tunnels. When Mariette opened one of the boxes using explosives, he found nothing. No remains, no treasures, only an empty interior with remarkably smooth walls. Today, scholars identify this site as the Serapeum of Saqqara, traditionally believed to be the burial place of the sacred Apis bulls. But here's the mystery. None of the open boxes contained the preserved remains of bulls or any evidence of mummification. Instead, researchers found something even more astonishing: the incredible precision of the stonework. Engineer Christopher Dunn, who spent 49 years working in advanced manufacturing, measured the interior surfaces of 2 of the granite boxes using industrial-grade precision instruments. He found that the internal surfaces were flat to a level of accuracy that rivals modern machining. The interior corners form perfect right angles, and the radius of the inside corners measures less than 4 millimeters. Dunn even contacted an American manufacturing company and asked whether they could produce an identical box from a single block of granite. Their answer was surprising. It could not be done, even with an unlimited budget. They said it would have to be assembled from 6 separate pieces. Yet the ancient builders carved each box from a single block of granite, transported from Aswan, nearly 800 kilometers south of Saqqara. Most of the boxes are made from extremely hard granite, while some are carved from diorite, an even harder stone. Even more puzzling, the underground passages are so narrow that 2 people can barely walk side by side. So how were these enormous blocks transported through such confined tunnels, maneuvered around tight corners, and positioned with gaps of only about 40 centimeters between them? No definitive explanation exists. There is no evidence of giant cranes, hydraulic lifting systems, or enough working space for large construction crews inside the tunnels. One unfinished granite box still sits in the middle of a passage, as if the workers suddenly stopped their work and never returned. Even stranger, the rough hieroglyphic inscriptions carved on the outside of the boxes differ dramatically from the flawlessly finished interiors. This has led some researchers to wonder whether the inscriptions were added long after the boxes themselves had already been completed. If you think the traditional explanation of history leaves too many unanswered questions, stay with us. And in your opinion, why would a structure said to be built simply for burying a bull require such extraordinary precision? Now we leave the underground passages of Egypt and travel beneath the waters of the Mediterranean Sea, where the next mystery begins. A violent storm struck a sponge-diving ship near the Greek island of Antikythera. Hoping not to lose valuable time, the captain sent one of the divers to inspect the seabed. The diver quickly returned, terrified, claiming he had seen human bodies lying 60 meters below the surface. The captain descended himself and discovered that what the diver had mistaken for bodies were actually marble statues scattered across the wreck of a Roman ship that had sunk around 50 BC. Among the statues, coins, and other artifacts was a small lump of corroded bronze. The object sat unnoticed for nearly 2 years in the National Archaeological Museum of Athens until politician Spiridon Stace noticed a small crack running through it. Looking inside, he saw something extraordinary. A tiny bronze gear. Finding precision gears inside a 2,000-year-old artifact shocked the archaeological world. Some even claimed it had to be a forgery, but modern CT scans settled the debate. The scans revealed an astonishing mechanism containing 37 bronze gears. The largest measured 13 centimeters in diameter and had 223 precisely cut teeth. About the size of a modern laptop, the device could calculate the positions of the sun, moon, and 5 known planets, predict solar and lunar eclipses, track the schedule of the Olympic Games, and even display the phases of the moon. European science would not achieve comparable mechanical sophistication for many centuries. The mechanism even accounted for the moon's changing speed in its elliptical orbit using 2 offset gears, a principle remarkably similar to the differential gear used in modern automobiles, allowing wheels to rotate at different speeds while turning. The gear teeth were cut with such remarkable precision that they appear almost machine-made. CT imaging also revealed inscriptions on the backplate that served as a complete instruction manual for operating the device. Although the front indicators have been lost, researchers believe they originally featured small colored spheres, a red one representing Mars and a golden one representing the Sunday. Researchers from University College London described the mechanism as a masterpiece, combining Babylonian astronomy with the mathematics of Plato's Academy. Whoever built it possessed an understanding of the heavens that would not be matched again for nearly 2,000 years. Even more intriguing, the Roman statesman Cicero wrote about a similar astronomical device built by Archimedes centuries earlier in Syracuse. If that's true, the Antikythera mechanism was not unique. It may have been the last surviving example of an entire lost scientific tradition. While the ancient Greeks transformed the movements of the heavens into a remarkable bronze machine, blacksmiths in India were achieving another extraordinary feat. In the courtyard of the Quwwatul Islam Mosque in Delhi stands an iron pillar measuring 7.2 meters tall and weighing more than 6 tons. An inscription in Sanskrit links the pillar to Chandragupta II of the Gupta Empire. For more than 1,600 years, the pillar has stood exposed to monsoon rains, scorching heat, and changing seasons. Yet it shows only minor traces of corrosion, while ordinary iron would have rusted away long ago under similar conditions. Within just a few years, ordinary iron begins to rust. Even the Eiffel Tower must be repainted every 7 years to protect it from corrosion. When it was struck by an artillery shell, it suffered only a dent, but without constant maintenance, it would gradually deteriorate. The mystery of India's iron pillar began to be seriously investigated in 1912, when British chemists collected the first samples for analysis. Yet the answer remained elusive for 91 years, until Professor Balasubramaniam of the Indian Institute of Technology, Kanpur, published a groundbreaking study. Using X-ray diffraction, electrochemical testing, and microscopy, his team discovered what was happening on the metal's surface. The results showed that the iron contains about 1% phosphorus, while having unusually low levels of sulfur and manganese. This unique composition allows a thin layer of iron phosphate to form naturally on the surface, creating an invisible protective shield that prevents corrosion and even helps seal tiny cracks over time. With every cycle of rain and drying, a new protective layer develops, continuously repairing microscopic damage. In other words, ancient Indian blacksmiths created a natural alternative to stainless steel nearly 1,500 years before its invention. Their method relied on forge welding, heating the iron, and repeatedly hammering it in a way that preserved its phosphorus content, all without modern instruments, scientific formulas, or metallurgy textbooks. Even today, modern industry has struggled to reproduce exactly the same combination of composition and long-term corrosion resistance. More than 6 tons of iron have stood outdoors for over 16 centuries, without paint or protective coatings, continuing to resist rust in a way that still fascinates scientists. While ancient Indian craftsmen mastered iron, the Romans achieved something equally remarkable with light. Inside the British Museum sits the Lycurgus cup, the only complete surviving example of its kind. At first glance, the cup appears green when illuminated from the front, but shine light through it from behind, and it transforms into a deep ruby red. The surface of the cup depicts the myth of King Lycurgus, trapped among grapevines as the god Dionysus watches. Its beauty lies not only in its intricate carving, but in the glass itself. During the 1990s, electron microscope studies revealed that similar Roman glass contains incredibly tiny particles of a gold-silver alloy, each measuring only about 50 nanometers, thousands of times smaller than a grain of salt. When light strikes these nanoparticles, the electrons within the metals begin to oscillate, changing the wavelength of the reflected light. The silver particles create the green appearance under reflected light, while the gold particles produce the brilliant red color when light passes through the glass. This phenomenon is known as surface plasmon resonance, a principle now used in advanced optical sensors and modern nanotechnology. It appears that Roman artisans somehow ground gold and silver into nanoparticles invisible to the naked eye and mixed them into molten glass in precisely controlled proportions. Remarkably, in 2014, modern researchers were only able to recreate the same optical effect using millions of engineered nanoparticles, something Roman craftsmen had accomplished 1,600 years earlier without microscopes, lasers, or any knowledge of modern optics. The secret of this manufacturing technique vanished with the fall of the Roman Empire. Today, the Lycurgus cup remains the only surviving witness to that lost technology. Researchers are now studying the same principle to develop ultra-sensitive sensors capable of detecting contaminants in drinking water. A technology originally created for a ceremonial drinking cup may one day help protect millions of lives, nearly 17 centuries after it was first invented. While the Romans mastered the manipulation of light, civilizations in the ancient Near East may have been experimenting with electricity. In 1936, during the construction of a railway line near Baghdad, workers uncovered an ancient burial site close to the ruins of Ctesiphon, the capital of the Parthian Empire. Among the artifacts was a small clay jar, about 14 centimeters tall. Inside the jar was a copper cylinder, with an iron rod suspended in its center without touching the sides. The opening had been sealed with bitumen, a natural asphalt. When Wilhelm Koenig, director of the Iraqi National Museum, examined the object, he immediately noticed that its design closely resembled a simple electrochemical cell. It contained 2 different metals, separated by a space that could hold a conductive liquid. Signs of corrosion suggested that the jar had once contained an acidic solution, possibly vinegar or grape juice. To test the idea, American researcher Willard Gray built an exact replica of the artifact and filled it with grape juice. The result was remarkable. The replica generated a measurable electric current. It could produce about 1 volt of electricity. By connecting several of these jars together, it may have been possible to generate enough power for electroplating jewelry with gold. Similar vessels have been discovered at nearby archaeological sites, along with iron and bronze needles. Interestingly, the Roman physician Scribonius Largus described treating gout by using the electric shock of a torpedo fish, suggesting that the idea of using electricity for medical purposes was already known in the ancient world long before modern science understood electricity. The artifact became known as the Baghdad battery because it predates Alessandro Volta's formal invention of the electric battery by at least 1,600 years. Tragically, in 2003, the artifact was stolen from the Iraqi museum during the invasion of Iraq, and its whereabouts remain unknown to this day. With its disappearance, humanity may have lost the opportunity to study what could have been the oldest electrical device in history using modern scientific techniques. Now we return to Egypt, but this time to an object small enough to sit on a tabletop, yet one that looks astonishingly like part of an industrial machine. In 1936, archaeologist Walter Bryan Emery excavated the tomb of the Egyptian official Sabu at Saqqara. Near the skeleton, he discovered a broken stone disc measuring 61 centimeters in diameter, carved from an extremely fragile type of schist that easily fractures. The disc features 3 elegantly curved blades connected to a central hub. Viewed from above, it bears a striking resemblance to the impeller of a centrifugal pump. The tomb dates back nearly 5,000 years, to Egypt's first dynasty, when tools were made primarily from stone and soft copper. So how were such thin, delicate blades carved from such brittle stone without cracking or breaking? No one has a definitive answer. One enthusiast created a 3D printed replica, mounted it on a rotating shaft, and tested it in water. When spun, the disc moved water surprisingly efficiently, producing a clear, swirling flow similar to the action of a centrifugal impeller. Even without a surrounding housing, the rotating disc generated a visible vortex, making its resemblance to modern pump designs seem more than mere coincidence. Engineers at Airbus also produced similar models and confirmed that the object's geometry possesses interesting aerodynamic characteristics, although it would not function effectively as a propeller. Egyptologist Cyril Aldred proposed that the stone disc may have been a copy of an earlier metal component. If that hypothesis is correct, the object could represent the surviving trace of an engineering tradition that disappeared before recorded history. Perhaps, 5,000 years ago, someone understood the principles of moving water through centrifugal force, and that knowledge vanished with its creators. Our final discovery was not buried underground. Instead, it stands before thousands of visitors every day near the Chinese city of Xi'an. In 1974, local farmers digging a well uncovered fragments of a life-sized clay statue. Their discovery led to one of the greatest archaeological finds in history, the Terracotta Army. More than 8,000 life-sized warriors were eventually revealed, each with unique facial features, although their heads were assembled from only 8 basic facial models. These soldiers were created to guard the tomb of Qin Shi Huang, the first emperor to unify China. Although less than 1% of the enormous archaeological complex has been excavated, the greatest surprise wasn't the statues, it was the weapons. Archaeologists recovered more than 40,000 bronze arrowheads, along with swords up to 95 centimeters long, spears, and crossbow mechanisms. After more than 2,200 years underground, many of the blades remained sharp, polished, and seemingly untouched by time. For decades, researchers believed the secret lay in a chromium coating, since traces of chromium had been detected on the weapons, even though chromium plating was not developed in Europe until the 20th century. However, a 2019 study completely changed that understanding. Researchers discovered that the chromium actually came from the protective lacquer applied to the wooden handles and shafts, not from a coating intended to preserve the bronze itself. The real secret turned out to be the combination of an exceptionally well-made bronze alloy and the unique characteristics of the local loess soil. Its alkaline chemistry, fine particle size, and extremely low organic content created ideal conditions for preserving metal. When researchers buried experimental bronze samples in the same soil, they remained remarkably well preserved. Identical samples buried in British soil corroded significantly over the same period. In other words, craftsmen of the Qin dynasty, more than 2,200 years ago, had unknowingly selected both an ideal alloy and an ideal burial environment. The Nile River has flowed through the world's largest desert for more than 30 million years without ever drying up. Surrounding it lies the Sahara Desert, where years can pass without a single drop of rain. Temperatures in the shade can reach 58 degrees Celsius, 136 degrees Fahrenheit, and entire mountain ranges lie buried beneath vast seas of sand. Yet through this barren landscape, a broad ribbon of blue water winds its way across the desert, sustaining fish, birds, wildlife, and millions of people. Every year, the Nile once overflowed its banks before retreating, leaving behind a layer of rich, black silt. The ancient Egyptians called this fertile land Kemet, meaning the Black Land. From this name came the identity of a civilization that flourished along a narrow green strip surrounded by endless desert. But one question is rarely asked. Why does the Nile exist at all? Where does all this water come from in one of the driest places on Earth? How does a river crossing the Sahara never dry up, while providing water to more than 100 million people? The answer lies thousands of kilometers south of Egypt, in mountain ranges that most people have never noticed on a map. The Nile is actually formed by two great rivers, each with its own story. The White Nile begins in Central Africa near Lake Victoria in Uganda, and flows steadily through the wetlands of South Sudan. The Blue Nile rises from Lake Tana in the Ethiopian highlands, nearly 2,000 meters above sea level. It supplies about 85% of the Nile's water and carries almost all of the fertile volcanic sediment that transformed Egypt into one of the world's great agricultural civilizations. Each year, between June and September, powerful monsoon rains drench the Ethiopian highlands. The floodwaters rush through deep valleys, carrying reddish volcanic soil downstream. Weeks later, those waters arrive in Egypt as the annual Nile flood. For nearly 5,000 years, Egyptian life revolved around this rhythm. Flooding in July, planting in October, harvesting in March. Without this cycle, there would have been no pyramids, no hieroglyphs, no pharaohs, no papyrus, and perhaps no ancient Egyptian civilization at all. Yet what truly puzzles scientists is that this system has continued for over 30 million years. Continents shifted. Climates changed. Ice ages came and went, but the Nile continued flowing northward toward the Mediterranean Sea. Geologist John Daniel Stanley studied sediments in the Nile Delta and found that the river's course has remained remarkably stable for at least 7 million years, dating back to around the time when the evolutionary lineages of humans and chimpanzees separated. That means the Nile is roughly 30 times older than our own species, and far older than anything we call human history. Its remarkable persistence can be traced to a major geological event. Around 30 million years ago, the African tectonic plate began splitting apart, forming what is now known as the East African Rift System. This enormous chain of rift valleys stretches from Mozambique to the Red Sea. As the land fractured, mountain ranges rose along both sides, including the Ethiopian highlands. Those highlands became a natural barrier that captures seasonal monsoon rains and feeds the Blue Nile, Without them, the Blue Nile would not exist. And without the Blue Nile, the Great Nile River would likely shrink into a small seasonal stream that never reached the Mediterranean. The Sahara itself was not always a desert. Around 9,000 years ago, during a period scientists call the African Humid Period, or the Green Sahara, North Africa was covered with grasslands, forests, lakes, and rivers. Researchers have discovered ancient rock art deep within today's desert, depicting crocodiles, giraffes, elephants, and hippos. Radar imagery has also revealed the channels of long-lost rivers hidden beneath the sand. Below the Sahara lies one of Earth's largest underground freshwater reserves, the Nubian Sandstone Aquifer System. It contains an estimated 35,000 cubic kilometers of groundwater, much of it dating back to that wetter era. This is another reason the Nile survives. The river does not depend on rainfall over the Sahara. Instead, its water comes from distant regions where desert conditions have little influence. That is the real secret of the Nile. It survives local drought because it is continuously supplied by abundant water far away. Still, another mystery remains. The Nile travels more than 2,000 kilometers across one of the hottest deserts on Earth before reaching Egypt. Common sense suggests that such extreme heat should gradually evaporate the river. Scientists estimate that at temperatures around 45 degrees Celsius, 113 degrees Fahrenheit, with very low humidity, a river can lose approximately 5 millimeters of water per day through evaporation. Without additional sources of water, logic suggests the Nile should disappear after only a few hundred kilometers. Yet it never does. Scientists have identified several reasons why. The first is the river's deep valley. Between Aswan and Khartoum, the Nile flows through a relatively narrow, rocky corridor. Because the river is deep rather than broad and shallow, less surface area is exposed to the sun, reducing evaporation. The deeper and narrower a river is, the less water it loses. The second explanation has only become clearer in recent decades. Beneath the Nile flows a vast groundwater system that closely parallels the river itself. Hydrologists from Cairo University have found that groundwater beneath the Nile Valley is far more abundant than theoretical models once predicted. Some of the river's water seeps into underground rock layers, continues flowing beneath the surface, and later rejoins the visible river. In other words, the Nile we see may be only the visible portion of a much larger and more complex water system. The third factor involves the air above the river. Large volumes of flowing water create a localized microclimate. Humidity increases. Air temperatures immediately above the river decrease. As the air becomes more saturated with moisture, evaporation slows. In a sense, the Nile helps create atmospheric conditions that protect its own water. The more water it carries, the better it becomes at conserving it. Seen from space, the Nile Valley appears as a thin green ribbon cutting through a vast expanse of lifeless brown desert. In some places, this fertile strip is only a few kilometers wide. Beyond it begins the Sahara, where surviving even a few hours without water can become a life-threatening challenge. Remarkably, about 95% of Egypt's population lives on only 4% of the country's land area. The remaining 96% is largely unsuitable for permanent settlement. This simple geographical fact explains both Egypt's extraordinary population density and its dependence on a single natural resource. That dependence changed dramatically during the 1960s with the construction of the Aswan High Dam. Before the dam, the annual flood naturally renewed Egypt's farmland with fresh, fertile silt. When the dam was completed in 1970, the yearly floods came to an end. Lake Nasser trapped most of the sediment that had nourished Egyptian agriculture for thousands of years. Stretchin. The wildlife of the Nile deserves a story of its own. The river is home to around 170 species of fish, some of which have remained virtually unchanged for millions of years. One of the most famous is the Nile perch, one of the largest freshwater predators on Earth. It can grow to 2 meters, 6.5 feet, in length and weigh over 200 kilograms, 440 pounds. However, when it was introduced into Lake Victoria during the mid-20th century, it triggered an ecological disaster, driving hundreds of native fish species to extinction because they were unable to compete with this powerful predator. Another formidable hunter is the Goliath tigerfish, found in parts of the Nile basin. Armed with dagger-like teeth, it strikes its prey with incredible speed and force. The river is also home to the fascinating Nile elephant fish, which navigates muddy water by generating weak electric fields. Relative to its body size, its brain is often compared to that of humans in terms of complexity. Then there is the electric catfish, capable of producing an electric discharge of up to 350 volts. Ancient Egyptians believed its shock could help treat muscle spasms and other ailments. Perhaps no creature commands more respect than the Nile crocodile. The largest males can reach 6 meters, 20 feet, in length and weigh close to 1,000 kilograms, 2,200 pounds. Studies have shown that Nile crocodiles use at least 20 different vocal signals, including extremely low-frequency sounds that humans cannot hear. Many remain within the same territory for years, and local fishermen often recognize individual crocodiles by the shape of their snouts and the scars covering their bodies. The Nile crocodile has inhabited these waters since long before the earliest pharaohs began constructing their tombs. Archaeologists have even discovered 4,000-year-old mummified crocodiles, demonstrating the animal's sacred status in ancient Egyptian religion. Thousands of years ago, hippopotamuses also lived throughout the Nile, reaching as far north as the Delta. Today, they survive only in southern Sudan and Uganda, after centuries of intensive hunting eliminated them from northern regions. A single hippopotamus consumes around 50 kilograms, 110 pounds, of vegetation every day. Its dung, deposited directly into the river, serves as one of the most important sources of nutrients for fish in tropical waterways. Researchers estimate that a herd of 100 hippos can produce enough nutrients to support fish populations weighing dozens of tons. In this way, the hippopotamus feeds the river feeds the fish, and the fish feed the people. This natural cycle existed long before the first Egyptian kingdom emerged. The birds of the Nile are just as remarkable. Among the reed beds nest African moorhens and several species of ibis, including the sacred ibis, which the ancient Egyptians associated with the god Thoth, the deity of wisdom. Egyptologists believe this connection may have developed because the birds arrived each year around the beginning of the Nile flood. Towering above the river, the African fish eagle nests in tall riverside trees. Its unmistakable call echoes across much of East Africa. When diving for prey, it can reach speeds approaching 100 kilometers per hour, 62 miles per hour, and its attacks are remarkably accurate. Another impressive resident is the Nile monitor, Africa's largest monitor lizard. It can grow to 2.5 meters, 8 feet, in length and is respected by many local communities. Despite this, it is often hunted for its valuable skin. An excellent swimmer, the Nile monitor can remain underwater for nearly an hour. It also plays an important ecological role by feeding on crocodile eggs and scavenging animal carcasses, helping maintain the river's natural balance. Much has been written about the people who live beside the Nile, Yet some aspects of their civilization remain astonishing. Unlike the civilizations of Mesopotamia, the ancient Egyptians did not rely on vast networks of deep irrigation canals. Instead, they built large agricultural basins separated by earthen embankments. When the Nile flooded, these basins filled with water for several weeks. The soil absorbed moisture while fertile silt settled across the fields. Afterward, the excess water was drained through specially constructed channels. This was not irrigation in the modern sense. It was a sophisticated system that worked with nature rather than attempting to control it. Even more remarkable, one of the world's earliest tax systems depended on measuring the river itself. More than 4,000 years ago, Egyptian officials used nilometers, stone measuring structures, to record the annual flood level. If the water rose high, they expected abundant harvests and collected higher taxes. If the flood was weak, they anticipated poor crops and often reduced the tax burden on farmers. The famous nilometer on Rhoda Island in Cairo remained in use for over 1,000 years, creating one of history's most valuable long-term hydrological records. When researchers analyzed those records, they discovered that periods of unusually high or unusually low flooding often coincided with times of political instability. Floods that were too large destroyed villages. Floods that were too small brought famine. Between these two extremes, ancient Egyptian civilization flourished. Today, however, the Nile faces a challenge, unlike any it has experienced in more than 30 million years. In 2011, Ethiopia began constructing the Grand Ethiopian Renaissance Dam, GERD, on the Blue Nile. Today, it is the largest hydroelectric project in Africa. Once its reservoir is completely filled, it will be capable of storing approximately 74 billion cubic meters of water, an amount comparable to the Nile's annual flow through Egypt. Egypt views the project with deep concern. The country receives very little rainfall and depends almost entirely on a single river for its water supply. Any significant reduction in the Nile's flow could affect agriculture, food production, and the livelihoods of millions of people. For more than a decade, Egypt, Sudan, and Ethiopia have held negotiations over how the reservoir should be filled and operated. Despite years of discussions, no final agreement has yet been reached. For the first time in history, the future of Africa's greatest river has become closely tied to a modern geopolitical dispute. The Nile has survived shifting continents, changing climates, and repeated ice ages for more than 30 million years. Yet within a single century of human intervention, it has encountered challenges unlike anything in its natural history. And the surrounding desert has its own surprising story. Far from being lifeless, the Sahara supports far more plant life than most people imagine. Even in its driest regions, nearly 2,700 plant species have been identified, many found nowhere else on Earth. Among the most iconic plants of the Nile Valley is the date palm. It can survive temperatures exceeding 50 degrees Celsius, 122 degrees Fahrenheit, provided its roots can reach underground water. Where groundwater approaches the surface, oases emerge, living remnants of the ancient green Sahara. As the Nile approaches the Mediterranean Sea, it divides into several branches, forming a vast delta covering roughly 24,000 square kilometers. The Nile Delta is one of the world's largest river deltas and serves as a vital stopover for migratory birds traveling between Europe and Africa. Each year, it welcomes flamingos, pelicans, herons, and more than 200 species of migratory birds, making it one of the most important wetland ecosystems on the African continent. Today, however, the Nile Delta faces a growing threat. Each year, the Mediterranean Sea slowly erodes parts of the delta. For thousands of years, this land was constantly replenished by fresh layers of sediment carried downstream by the Nile. But after the construction of the Aswan High Dam, much of that sediment became trapped behind the reservoir. Without a steady supply of new deposits, the sea has gradually advanced into the delta's most vulnerable areas, a process known as sediment deficit. The Nile Delta is also home to many freshwater fish species, including tilapia and the Nile carp. Among them, tilapia has become one of the world's most important farmed fish. Today, it is raised in aquaculture facilities on every inhabited continent, even in cold regions such as Alaska and Scandinavia. Few people realize that the fish on their dinner plates are descendants of species that were already being caught by the servants of the pharaohs thousands of years ago. Farther upstream, in what is now Sudan, another great civilization flourished. The ancient kingdom of Kush rose along the Nile, and during the 6th century BC, conquered Egypt and ruled it for several decades. The rulers of the 25th dynasty, often called the Kushite dynasty, revived the tradition of pyramid building after it had largely declined in Egypt. In Nubia, they constructed more pyramids than were ever built in Egypt. Today, Sudan is home to roughly 250 pyramids, yet they remain far less famous despite being a direct continuation of the Nile Valley civilization. The Nile also gave rise to a unique type of soil known as vertazole, a dark, nutrient-rich clay. This soil expands dramatically when it absorbs water and develops deep cracks as it dries. Over millions of years, layers of Nile sediment created these exceptionally fertile lands. Their remarkable productivity allowed abundant harvests even without artificial fertilizers. Historical estimates suggest that 1 hectare of fertile Nile farmland could produce enough food to feed 10 people for an entire year. That was 3 to 4 times more productive than many European fields before the Industrial Revolution. This extraordinary fertility is one of the reasons Egypt became the breadbasket of the Roman Empire. Its success was not simply the result of hard work. It was the gift of an extraordinary river. Between February and May, Egypt experiences the Khamsin, a powerful desert wind that carries vast quantities of hot dust across the country. At first glance, these storms seem harmful to the Nile ecosystem, yet they also provide an unexpected benefit. The mineral-rich dust settles over the floodplain, adding nutrients that the river's sediment alone cannot supply. One of the Nile's most unusual characteristics is the direction in which it flows. For more than 6,000 kilometers, it travels from south to north in an almost continuous path. This unusual course is determined by the region's geology. The river follows the gradual slope of the Nubian swell, which naturally channels water toward the Mediterranean. In Sudan, it cuts through ancient Nubian sandstone, creating a broad and stable valley. Farther north, in Egypt, it flows across extensive limestone plateaus. These same limestone formations were carved into the famous tombs of the Valley of the Kings. Remarkably, this limestone originated from the remains of marine organisms that lived beneath an ancient sea more than 50 million years ago. In a sense, Egypt was built from the remains of a prehistoric ocean, while its river flows across what was once the seabed. The Nile is also home to the Nile softshell turtle, an extraordinary reptile capable of absorbing oxygen directly through its skin. This allows it to remain underwater for many hours without surfacing. Some fishermen in Sudan even call it the devil of the river, because it can suddenly bite anyone who disturbs it. Its jaws are powerful enough to snap a thick wooden stick, and wounds caused by its bite may take weeks to heal. Another unusual resident is a species of freshwater crayfish that can tolerate water nearly as salty as seawater. This remarkable adaptation allows it to survive in the Nile Delta, where fresh and salt water mix together. By thriving between 2 different environments, it has turned a difficult habitat into a survival advantage. According to ancient accounts, Cleopatra praised Nile mud as a natural cosmetic for maintaining healthy skin. Modern scientific studies have shown that Nile mud contains fulvic acids, humic substances, and numerous minerals with anti-inflammatory properties. Even today, therapeutic mud treatments offered at some Egyptian spas rely on the same type of Nile mud that Egyptians were using more than 3,000 years ago. Perhaps Cleopatra's beauty rituals were not merely legend, but practical applications of a naturally beneficial material. In ancient Egyptian mythology, the annual Nile flood was explained as the tears of the goddess Isis mourning the death of her husband Osiris. Although poetic, the legend reflects a real natural phenomenon. When heavy rains fall across the Ethiopian highlands, the Blue Nile carries enormous amounts of iron-rich volcanic soil. The water turns a dark reddish brown before eventually reaching Egypt. To ancient observers, the changing color of the river resembled blood or tears. That crimson flood announced the beginning of the inundation, bringing either prosperity or destruction depending on its intensity. The entire Egyptian religious calendar was built around this natural cycle. Priests who monitored the annual flood held tremendous influence, not only because of religion, but because they could accurately predict the coming harvest. Their forecasts were based not on miracles alone, but on centuries of recorded nilometer measurements compared with historical records. In many ways, this represented one of humanity's earliest forms of hydrological forecasting. Today, satellite imagery reveals a striking contrast. A narrow ribbon of green separates fertile land from endless desert. The boundary between life and barren sand is often no more than a few meters of water. Thousands of years ago, the people of the Nile understood a truth that modern science continues to appreciate. Civilization cannot be separated from the river that created it. Today, the challenges facing the Nile extend far beyond environmental concerns. Dams, climate change, rapid population growth, and increasing water demand raise an even larger question. Can humanity truly manage natural systems more complex than anything it has ever built? For more than 30 million years, the Nile managed itself with remarkable stability. If one day it were to fail, not because of nature, but because of human conflict, we would lose far more than a river. We would lose a living system that existed millions of years before humans themselves and the foundation upon which one of history's greatest civilizations was built. The Nile was never just a river crossing a desert. It was the reason civilization could take root there in the first place.